Hello back to Prep Math. Today we are going to talk about linear system of equation and we are reaching chapter 5 of our preparatory course. So in this chapter we will look in more details at different methods to solve system of equations such as addition, substitution methods, graphical interpretation, and Gaussian elimination. And we start by revising the most common methods, which are addition and substitution. In previous chapters, we got familiar with linear equations. So when multiple equations need to be satisfied simultaneously, we call it a system of equation, like here. A linear system of equation has more than one unknown that we also call variables. So here our variables will be x and y. Normally, we number the equations in a linear system in order to make referring individual equations easier, because we will do some manipulations later so that you will not get lost which exactly equation we mean. We just number them. A solution to a linear system equation with n unknowns called n tuple. So, for example, here we have two unknowns, which is x and y. A solution will be called pair. If we will have three unknown, then it will be called triple. For 4, it will be quadruple. So it will just depends on how many variables we have. The solution set will include all the numbers that can satisfy this linear equation. There are several methods to find the solution set. And the first method that we will revise is addition, which is also called elimination method. The method involves adding equations together in order to remove at least one of the variables from the system. To implement this, we usually do suitable transformation of equations that we already learned in the previous chapters. So for example, let's solve this system by using addition method. Let's say we want to get rid of variable x. If we look carefully, we can see that if we multiply the first equation to -2 and the second one to 3, we can get rid of x when adding them to each other, because it both will give us -6 and 6. So let me just rewrite it here. So the first equation multiplied to -2 will give us -6x plus 8y equals to -4. And the second equation we multiply by 3 and get the following. 6x plus 9y equals to 21. So if we add first equation plus second equation, here we will have 0 or nothing. Here we will have 17y equals to 17. And thus we find out that y is equals to 1. Then we put this result to one of the original equations. Let's put it on the first one here. So 3x minus 4 multiplied to 1 equals to 2. And then we'll have 3x equals to 2 plus 4, which is 6. And thus x will equal to 2. So our solution set will be here. Pair 2 and 1. We can always check it back by putting both solutions into the original equations and check whether they hold. Next method to solve a linear system of equation is substitution. In comparison to the addition or elimination method, the substitution method has one notable advantage. It can also be performed for nonlinear system of equations. For example, this system that contains quadratic term. So what we do? Firstly, we solve one of two equations for one variable. So let's take this one because it's linear and it's easier to solve. So we solve it for one of the variables. You can just choose one. And let's solve it, for example, for y. So y equals minus x. -2 So we have this one here. Now we put the solved expression back to the first equation and solve it. So we will put this back instead of y here. And then we write this one here. So it will give us x squared plus 2x plus minus x minus 2 equals to 0, which will give us x squared plus x minus 2 equals to 0. I would recommend you to pause the video now and solve this equation by using any methods you prefer, and then come back to check the results. Alright, I hope you solved it successfully. Now we can just check. I would just use the PQ formula and start calculating the discriminant, which is p divided by 2 squared minus q, and it will give us 1 divided by 2 squared plus 2, which is 9/4. And x1 in this case will be minus p divided by 2 minus square root of d, which is minus half minus 3 divided by 2, and this is minus 2. x2 will be minus p divided by 2 plus square root of discriminant. This gives us here plus 3 seconds, which is 1. So now we got that x1 is equal to minus 2 and x2 is equal to 1. So with the solve equation from step 1, we can just go back and calculate the value for y, which are right here. So we take x1, so y1 will be 2 minus 2, which is 0, and y2 will be minus 1 minus 2, which is minus 3. So the solution set for our linear system of equations will be two pairs. Pair of x2, y2, and second pair x1, y1. That's it. This is a substitution method. One more way to solve a linear system of equation is equality method, which is also valid for nonlinear systems. Let's use the equality method to solve the same linear system as we saw before. So first of all, both equations need to be solved for the same variable. For example, let's say we will solve it for x. So to solve for x, we need to divide every variable here by 3 and then move them to the other part. So it will give us x equals to 2/3 plus 4/3 multiplied by y. And in order to solve this equation by x, we need to divide every element by 2. And for the second one, we will get x equals to 7 divided by 2 minus 3 divided by 2 multiplied by y. So if the left side of the equation is the same, then right side should be also equal to it. So we can just take this part of equation and equal it to this part. It will give us 2/3 plus 4/3 multiplied by y equals to 7 divided by 2 minus 3 divided by 2 multiplied by y. To solve this, we can just multiply both parts by 6. So we just get rid of all the fractions. It will give us 4 plus 8y equals to 21 minus 9y. And from here, we move y for the one side. 8 plus 9 will be 17. It will be 17y equals to 21 minus 4, 17. And y will be equal to 1. So we got the answer here. And since we get the y equals to 1, we again put it on the first equation, for example. Or we can also put it somewhere here. Will be the same. So let's try this one. So x is equal to 2/3 plus 4/3 multiplied by 1, which is 6/3, which is 2. And we will end up having same solution set, which is 2 and 1.